I am so, my co-PIs and I are so honored that you chose this project. This is about carp remediation. It's climate change, ecological, and economic benefits. And my co-PIs are Przemek Bayer and Brian Huser. And I'm John Downing. I'm from the Large Lakes Observatory. That's where my research home is, UMD Department of Biology and Minnesota Sea Grant. And Przemek is with MAISRC and the Department of Fisheries, Wildlife, and Conservation Biology. And Brian is over in Sweden, but will be coming and helping us with this really, I hope, very interesting project. Picture's worth 1,000 words. On the left, you see a lake with about 100 pounds per acre, kilograms per hectare of carp. The manipulated side, carp removed. A couple of days after, from Laura Schrage's work, suspended carbon dropped by 90% and phosphorus concentrations were down by more than 50% in that short period of time. So it's obvious that then I just want to mention we're talking about Cyprinus carpio here, which is the common carp. Some things we know about carp in lakes are that they're damaging invasive fish. They decrease the biodiversity and abundance of aquatic plants, of benthos, of waterfowl, of amphibians and fish. They reduce the recreational value of lakes. They uproot aquatic macrophytes. They increase eutrophication, increase sediment resuspension. They change lakes in very important ways. Now, Przemek and Brian and I feel that carp in lakes may also influence the global carbon cycle. Lakes are a big key to the global carbon cycle. They emit carbon dioxide, methane, and nitrous oxide, which are important greenhouse gases. They also are important in carbon sequestration for sequestering carbon in sediments. They change particulate organic carbon, DOC, DIC, via oxidation and creation. And they also impact the amount of carbon exported downstream. And in fact, they capture globally something like 2/3 of the carbon transported from land, lakes do. So pretty important in the global carbon cycle. In fact, they're so important that projected changes in lakes by 2050 mean that lake methane impact alone will equal something like 25% of fossil fuel burning and 150% to 300% of land use change. And lake greenhouse gas output will counterbalance something like 100% of oceanic carbon burial and 50 to 100% of terrestrial burial. So we're not talking about minor effects here. Now, what we don't know about carp in lakes, here's Lake Mead, just to show you there's kind of a lot of carbon sequestered and people find this out to their peril. Things we don't know that we want to know is how do carp impact carbon sequestration? How do carp impact lakes' greenhouse gas emissions? And how does that translate to societal climate-related costs? How we think carp impact carbon cycling is basically by stirring up and mixing sediments and creating more plankton growth, which creates more labile carbon, which can be degraded more quickly and turned into inorganic nutrients and gas diffusion. And so you see a big red arrow going down into the sediments caused by carp and a big red arrow going up in terms of gases and nutrients being emitted from sedimentary environments. Now, since carp increase eutrophication, they should also drive up greenhouse gas flux because carbon dioxide, methane, and nitrous oxide emissions all increase with eutrophication. Our objectives are to contrast lakes with diverse biomasses of carp to figure out how carp impact sediment carbon sequestration, how carp impact greenhouse gas emissions, and how carp impact the climate change and economic benefits of carbon renewal. The methods I'll skim through pretty fast. We'll be sampling 18 lakes that are physically similar. We are going to sample 6 that have abundant carp, 6 that are managed lakes with low or no carp. It's pretty hard to get all carp out of systems, and lakes where carp have not been detected. So 6 different kind of treatment areas of lakes that are physically similar. We'll Progemic will be mostly working on determining the relative abundance of carp and macrophytes among these systems, and that'll be determining CPUE by electrofishing, sampling, and random intercept method for macrophytes. Brian will be working on determining sediment deposition rate history by slicing up cores to determine the active layer and the amount of labile versus recalcitrant carbon and phosphorus, and also by analyzing lead-210 in those cores to determine carbon burial rates. And then my part of this will be looking at greenhouse gas emission by direct estimation of methane, CO2, and nitrous oxide emissions. And the CO2 will be measured directly, and methane and nitrous oxide by floating chambers, so that we can get diffusive as well as ebullitional flux. Then the social cost of greenhouse gas emissions will be determined by standard methods of integrated economic assessment. Statistical analyses then among these different treatments, so will assess carp's multiple impacts. We will also do a fair bit of community engagement from the beginning, engaging the public and policymakers in the benefits of carp benefits of managing carp and other aquatic invasive species. And between MAISRC and Minnesota Sea Grant Communications, we'll be translating our results rapidly to management actions, and we will be guided throughout the project by a stakeholder focus group. And this focus group will be composed of people likely to apply the results, people whose livelihoods are influenced by carp management decisions, also those in public policy positions regarding carp, water quality, AIS, and lake restoration. We hope that this group will complement MAISRC's Carp Research and Management Group, and will be including tribal governments, Minnesota DNR, MPCA, Department of Health, the Soil and Water Conservation District, and several other groups in guiding the work and getting this information out once we begin to do the science. So here's a picture of one of my friends holding his trophy carp. We call this carp and carbon, and I think this is a local AIS problem that has global implications. And I'd just like to close by expressing my thanks to MAISRC and the ENRTF for giving us the chance to do this research. We're very excited to kick it off. And thanks very much for inviting me, Ethan, to talk today. And I will look forward to answering questions if we have time.
Thanks so much, John. If anybody has any questions for John, you can go ahead and use the Q&A button at the bottom of your screen. Next up, we have Josh.
Hello. I will be talking about a new project for next year, effective rusty crayfish trapping removals to protect wild rice. I'm working on this project with my co-lead, Tyler Casper, at the 1854 Treaty Authority. And the 1854 Treaty Authority is contributing a substantial amount of staff time to do project planning and a lot of field work over 2 years, as well as partners at Lake County Soil and Water and Cook County Soil and Water. Liz Anderson and Amanda Weberg are contributing to this project as well, providing staff time and project planning. So we have a good group of partners working on this, people that I'm working with that have more experience trapping rusty crayfish than I do and working in the lakes that we're going to be selecting as study lakes. So rusties and rice in Northeast Minnesota. Rusty crayfish are not trapped on the DNR infested waters list. They show up as occurrences from local fisheries offices and in DNR Lake Finder. If you look through fisheries surveys, you'll see mention of rusty crayfish being present or not, or it's local reporting from soil and water conservation districts. So this map of rusty crayfish presence in Northeast Minnesota was generated in the St. Louis County Invasive Species Risk Assessment tool that myself and Chrissy Nixon put together back in, I think, 2017, and it was updated 2 or 3 years ago now. In this area, there are 75 lakes in St. Louis, Lake, and Cook County that have rusty crayfish. 35 of those are listed on the 1854 Treaty Authority as wild rice waters. So we have 35 lakes that have rusty crayfish and wild rice. And nearly anything that rusty crayfish can grab with their claws is food, whether it is dead fish or snails or other invertebrates on rocks. Particularly tender shoots of new vegetative growth seem to be grazed upon. And wild rice is susceptible to crayfish grazing in the germination to submerged aquatic growth phase. So this is when it's growing underwater, especially new shoots coming up from the sediment. Once wild rice reaches the floating and emergent phases later in summer, it's pretty safe against crayfish grazing and uprooting, but it's that early growth phase in May to June when it's really vulnerable. And a 1854 Treaty Authority technical report in a very simplified summary kind of alludes to the point that wild rice density is reduced when it's grown in the presence of rusty crayfish. And the full citation for that and link is in the bottom of this slide and where you can find that technical report. So what we're going to do is basically crayfish trapping. Now, crayfish trapping has been around for a long time, especially rusty crayfish literature goes back 40 years, probably maybe even 50 years now. What we're going to do is be a little more selective in where we're choosing to collect our data rather than choosing the best traps to remove biomass. We're going to try and learn something about how rusty crayfish are interacting with these wild rice growth areas. So we're going to select 6 Northeast Minnesota lakes. 3 will be sampled in 2023 and 3 will be in 2024, where we have rusty crayfish and wild rice. If we can't find 6 perfect lakes, we'll use suitable surrogate habitat or vegetation. And I can imagine it may happen where there's a bay with a lot of vegetative growth, but very sparse rice growth. And so we're going to have to make some of these decisions on which lakes we select once our project is started and we're reviewing our possible lake choices. Each lake will be trapped in 2 periods. That early May to June period when rice is just starting to grow and when it's vulnerable to grazing. This would be finding trapping methods that would be immediately protective, reducing crayfish at the location where rice is growing when the rice is vulnerable. And then again, we're going to come back to the same lakes and trap again in July or August in this emergent phase. Now, based on published literature, we expect a lot higher catches at this time. Rice isn't directly grazed upon by rusty crayfish at this time, but we're going to get greater catches. And we want to see if this has any potential of reducing pressure on next year's wild rice growth. The lakes that we're going to be looking at are large. Many are connected in chains of lakes or connected by streams. So it might be completely impractical to try and trap out a lake, but you might be able to do localized reductions in a bay or a section of a lake where wild rice is growing. Is there any impact to reducing the population near wild rice when you have an open system like that? So our 2 objectives are to determine the most effective trap type and bait for rusty crayfish removal, particularly among these 2 time periods, and measure rusty crayfish migration rates into depleted removal areas. For our first objective, we're going to test 3 different trap types. The standard is this labeled as A. It's a minnow trap that's just modified to have slightly larger openings to accommodate crayfish crawling in. The second is a very similar design. All that's included there is a center conical section to make it larger, thereby increasing the capacity before it fills up or before crayfish can simply walk across the backs of other crayfish and more easily find those cones to walk out of the trap. And a different trap type that there isn't much literature on for rusty crayfish but it's used more frequently in Europe, is a refuge trap. And this is a series of pipes that crayfish will crawl into to hide. And they're not baited. It is a passive collection trap. And there's been a lot of reporting that it's a much higher female catch ratio than the baited traps. Baited traps are predominantly male biased. Large aggressive males will enter the traps, and it might not be until you remove many of those large males that females feel comfortable entering the traps. So we want to see how these refuge traps pan out for reducing females, because the species only really lives about 4 years. If you can hammer the reproductive capability, maybe you can reduce the population rather quickly. And the traps that are baited, A and B, will be baited with 3 different bait choices: hot dogs, cat food, and frozen fresh fish. Frozen fresh fish is reported to be, absolutely the best for capture, but there's a lot of variability. Last year I trapped with cat food and beef liver, and the catch really flip-flop between the two. One lake they liked one lake they liked another. So there may be a lot of variability among bait choice. These all may be pooled together, and we'll end up just using the trap style to use in our data analysis. And when we catch the crayfish, we're going to be grading them through a grading box. So we separate large and small, sexing males from females, and then doing counts. So we can calculate catch per unit effort among the different trap types and baits. And we're going to follow all of the guidance for legal trapping. So we're not creating anything new or special or outside the regulations, so that if anybody was applying these methods in a lake, they wouldn't have to get any special permissions or anything like that. For our second objective, we're going to be seeing how far rusty crayfish are moving. Remember, these are going to be open systems, and we're going to be doing localized removals. So it's possible crayfish could just move in if they wanted to. We're going to create a zone of a depleted population near wild rice. So outside of that removal area by the wild rice, we're going to set additional traps where we're marking and releasing crayfish. So in our May to June trapping period, we're going to mark rusty crayfish by poking holes in their uropods and then releasing them. And there's going to be a pattern of marking them, which is shown in this image, on where on the uropod and how many holes that they're going to be marked with. Then when we come back to the same lakes in July and August trapping period, we're going to hopefully recapture marked crayfish in both removal and release areas and determine how much crayfish are moving around. And then we can decode where they were originally marked based on the hole pattern and see exactly where they came from versus when we recaptured them. So this is kind of what we hope to learn in a summary. What trapping method removes the most crayfish per unit effort, particularly in May and June near the areas of wild rice growth? What method removes the most females or the most biomass? So we're trying to see if there could be localized population depletions near rice, and what methods are most economical. We're going to consider the cost of traps, how difficult they are to use or stack or transport or build, and what methods capture large crayfish, which could be a way to elicit recreational harvest, or perhaps if there ever is a commercial harvest or commercial market for rusty crayfish, which methods are getting the large ones. And how do rusty crayfish move in a lake? Are localized reductions near wild rice sustainable? And that's going to be one of the important themes as we get through our findings. So that was it for the intro to that new project. Thank you. I'll take questions through Q&A.
We've got a, let's see, we have a question here from Gary. If you encounter native crayfish in trapping, will you remove those or leave them?
We are leaving native crayfish. We wrote in our proposal we would throw them back.
That's great. Are there any other questions for Josh at this time? And you can ask any of our presenters here today any question you want at any point. We can certainly pull folks back in to answer Here's another question from Gabrielle. How are rusty crayfish affecting that environment?
It depends on the abundances in the lakes, but where they are abundant, they have been documented as uprooting and grazing upon vegetation to the point that it can disappear from entire shoreline areas. They can eat snails and other aquatic invertebrates. That is going to be important food for native fish and other things. So that's where the difference between rusty crayfish and native crayfish may lie, is strangely how abundant they become once they inhabit a lake. They seem to be under every rock once they get into a lake.
Thanks for answering that question. And there's still time to ask questions of Josh. We can move on now to Dan Larkin's presentation on his new project. Dan, take it away.
Great, thank you, Ethan. Really enjoyed John's and Josh's presentations. And let me just get my screen sharing going. And I want to echo the appreciation for funding from MAISRC and ENRTF for this new project. So sticking with the wild rice theme, the title of our new project that's starting up is Starry Stonewort and Wild Rice, Assessment and Response. I first want to highlight this great group of collaborators who will be involved in this work. Several people from the University of Minnesota, including Steve Smith, who's a PhD student in my lab, who will be working on this project as part of his dissertation. We have collaborators from the Leech Lake Band of Ojibwe, Kate Hagston and Rainey White from their Department of Resource Management, and from Boston University, Ranjan Muthukrishnan, who presented earlier today in a session that you might have been in on some of his research. So a tale of two species. Actually, Alex Badges earlier today did a tale of two, nod to a tale of two cities, and I'm doing the same metaphor. So wild rice, which you just heard about from Josh, it's an aquatic annual grass. We find it growing on mucky sediments in slow flowing areas of lakes, streams, and rivers. And it's sort of a Goldilocks species that likes things just so, with clear water, with stable, shallow depth, less than about 3 feet. And it's a really important species in a lot of ways. And of course, one of those ways is culturally and nutritionally and spiritually. So its Ojibwe name is Minomen, referring to the good seed or the good grain. And it's really central for many Native people throughout the Great Lakes region and many people of Native and non-Native alike in Minnesota, as an irreplaceable resource. Unfortunately, we see this pattern of long-term decline across the upper Midwest and sort of a shrink in its geographic range and the watersheds that it's found in and its local abundance, as Josh was talking about. And Minnesota is really a stronghold. If you look at sort of the main states for this species of wild rice, Minnesota, Wisconsin, and Michigan, there have been losses across the board, but we've sort of have the most remaining here in Minnesota. And so its conservation is a high priority. And then the other species to introduce is starry stonewort, which you've perhaps heard about in earlier sessions today. It's a type of green algae called a charophyte. And again, you see it growing on mucky sediments in slow flowing, relatively clear and shallow water. So starry stonewort has been an aquatic invasive species of concern for wild rice, given, like Josh was saying with rusty crayfish, this people recognizing that there seemed to be some overlap in starry stonewort lakes with areas that had wild rice, have a kind of a generally overlapping geography. And as I alluded to before, these sort of similar habitat associations, potentially looking for the same things. And we now have good evidence that starry stonewort invasion does indeed decrease native plant abundance. So this is from Carly Wagner's master's thesis. She's now with the Minnesota DNR as an AIS specialist. And this is showing for 3 Minnesota lakes, the relationship between abundance of starry stonewort on the bottom axis and then native plant cover on the vertical axis. And we can see this consistent pattern of decline. So as I mentioned, the starry stonewort has been a concern in regards to wild rice, and this sort of came to a head last summer when starry stonewort was found in Leech Lake, and in an area where it was spreading into a significant wild rice bed that's been used for harvest for a long time. There is an effort underway bringing different groups together on Leech Lake to do a dash removal. Dash stands for diver assisted suction harvesting. So the intent here is to reduce this population of starry stonewort and knock it back using this physical removal method where you have divers pulling up the starry stonewort and basically putting it into a large vacuum tube. This find on Leech added to the starry infestations that were known on the Leech Lake Reservation, notably Cass and Winnipegashish. And this image shows, this is a really lake dense area. And so there are a lot of other lakes that are potentially at risk that have that proximity to these starry stonewort populations and likely overlapping environmental conditions that would be amenable to starry. So that's sort of the genesis of our project, was to address this problem in this context. And we have 3 main objectives. One is to improve surveillance for starry stonewort within and across Leech Lake Reservation lakes. If you saw Alex Badge's presentation earlier where he talked about Eurasian water milfoil and starry stonewort, it's going to draw on that work and has some parallels in that we want to use those types of models to prioritize discovery of new infestations, search of lakes that we don't know have starry stonewort, but then also for lakes where like Leech Lake, where we know we have starry stonewort, to prioritize search effort within those lakes to better characterize its full distribution. We also want to assess the impacts of starry stonewort invasion itself, as well as the management of starry stonewort on wild rice. So we think there are reasons why starry stonewort is likely to have negative impacts on wild rice, although there are some nuances to that perhaps we'll get into in the Q&A period. And then the hope is with the dash management that will kind of free the wild rice from the starry stonewort. But we want to look at both of those aspects of it. How is wild rice being impacted by the AIS, and how is it benefiting, hopefully, or not, from the management of starry stonewort? And then third, we want to provide research and extension support for Leech Lake Band and others in the area to improve capacity for starry stonewort surveillance and management. And that is all I have, and I will stop presenting and turn it over to see if there's anything in the Q&A for me or either of the other presenters. Thank you.
Yeah, I just got something for you that came in, Dan. Got a question from James. James says, many tribal groups do not currently support the use of herbicides on tribal lakes or near rice. Is there any tribal support for evaluating manual versus herbicide control of starry stonewort in rice lakes?
Yeah, that's a good question. Yeah, so that is one of the reasons that DASH was chosen here. There are some recognized limitations to the effectiveness of the algicides and herbicides we have available right now for starry stonewort. So it's, there's a need in general to innovate and look for other tools and solutions to get more effective starry stonewort control, but especially given that this is a ricing area, it's a priority for the tribe to not be using chemical control methods. I am aware of other tribes that are exploring DASH for this type of situation, but with Eurasian water milfoil in Michigan, I'm not aware of any current tribally supported efforts that are comparing physical removal methods with chemical control methods. Perhaps they're out there, but I haven't come across anything like that.
Thanks, Dan. Our next question is for Josh. Josh, Rusties are known to molt 4 times. Will molting cause them to lose those markings? And maybe it depends on what time of the year they molt, but can you talk about that a little bit?
Yeah, the marking strategy of poking holes is reported to last 2 to 3 molts. And between May, June, and July, August, we're hoping we won't exceed 2 molts. So we'll see. It's supposed to work. Others have used it. So we're going to try using it too.
That's a fair answer. Does anybody else have any questions for Josh, Dan, or John? Well, if there's any, we see one more question here. Let's see, Pleasant Lake in Wright County uses a combo of scuba removal and chemical for starry stonewort. So not really.
Yeah, that's a good point, Alicia. There are definitely efforts underway where physical and chemical removal is being applied jointly with starry stonewort. I think that is a good strategy. So yeah, in terms of my earlier answer, I don't know of any tribally supported management or studies of that nature, but it's absolutely an approach that is being used for starry stonewort in general. Thanks.
We've got one more question for Dan. What started your interest in starry stonewort?
Oh, good question. So I've been in this job for 7 years. I'm an associate professor and extension specialist. And one of the sort of goals of my position when I started was to do research on aquatic plant management and restoration and develop extension programs in those areas. And right after I moved here in August 2015, starry stonewort was found for the first time in Minnesota in Lake Coronis. And so it was, and it's not something that was really on people's radars here. And there were very few people at the time doing research on starry stonewort and nobody in the state. So it just kind of was sort of serendipity that we arrived at the same time. Although in the case of starry stonewort, it was found in 2015. It was undoubtedly there earlier than that.
I don't know, Dan. Seems suspicious. Maybe.
Yeah, I know. It did seem like something I could have introduced to, get my research going. But it is a really interesting species, and one of the things that makes it interesting is that it's a threatened and endangered species in most of its native range. So, the way we view wild rice here, wanting to conserve it and worried about its decline, that's the way it is for starry stonewort, where it came from, and then it just has does really well in some of our inland lakes in the upper Midwest. And there's, I see a question, how fast does starry stonewort grow? Quite quickly. We have used in past years some permanent monitoring transects where we scuba dive and sample those same plots a few years in a row. And I don't have a rate off the top of my head, but we saw these meter squared plots that hadn't had any starry stonewort the prior year overtaken by it. So it's it can spread on the order of a patch of starry stonewort can spread on the order of a few feet per year.
In instances of early infestation of starry stonewort, does physical removal pose a significant risk of fragmentation and spreading further throughout the lake?
It's something to be cognizant of in those efforts, but I think the best thing to do is hand pull it when it's at low abundance. So it's unlike regular plants that are longer lived and have true root systems. Starry stonewort just kind of has this shallow attachment to the sediment. So it's pretty easy to pull up. And so if you have people who are hand pulling it, being sort of careful and conscientious as they're hand pulling it and then bagging it and removing it, I think that's the best hope we have for containment. And Grand Lake is a good example of that, where starry stonewort was found near the access during our first Starry Trek event, and the Lake Association and DNR have been great at the sustained hand pulling effort and doing it multiple times per year. And so far it's been contained well. So I think, it's something to be careful about, but I think well worth the risk of things potentially floating away.